So after actually trying these electronic configurations for the first 20 elements as required in the syllabus, from element number 1 all the way to element number 20, being able to break down the ideas about periods into however many shells you have to fill in, as well as this being the first shell to fill in, this being the second shell, and the fact that there aren't anything else after that means that this is the outermost shell. So period 2, you only fill up to the second shell, and the group number tells you how many outer shell electrons you have. And for group 0, in fact, you don't use group 0, you use group 8, so there's a V for 5, and then number 3 for 5 plus 3 giving you 8. These are the Roman numeral system to represent group. These are the Arabic numeral system to represent period. So after that, there's a little bit of checkpoint for us to go through. So an atom of gold has 79 protons and 118 neutrons. So the number of protons plus the number of neutrons. So in the real exam, you really have to use number instead of NO. So I better write it down as such, otherwise there will be excuses that will come up later on that says that, I didn't do it like that. So it's the number of protons that come from proton number and number of neutrons that you can get by taking away from nucleon number. Okay, so nucleon number again is not the same as relative atomic mass. It's given in the periodic table, so you need to be very careful. The proton number simply tells you how many number of protons in the nucleus of an atom. So the nucleon number is going to be 79 plus 118. That will give you the nucleon or the mass number. Which one has the lightest? The lightest mass means the smallest mass. Not the heaviest, the opposite, not the heaviest. So the electron is about 1 over 2000 times the mass of one proton. So one electron is about 2000 times lighter than the mass of one proton. Is also about 1 over 2000 the mass of one neutron as well, because the mass of one proton is the same as the mass of one the mass of one proton is the same as the mass of one neutron. So electron is very light, and the mass of an atom is concentrated in the nucleus because the nucleus contains the protons and the neutrons. Next bit, the nucleon number. Okay, so if you write in the nuclide, which is the international accepted convention, this is not the periodic table notation. So I will write copper being the symbol Cu to represent copper. And because I'm writing the international standard notation, I don't write them in the middle like in the periodic table. Instead, I write on the far left. On the bottom left, at the bottom left is the proton number, so it's 29. On the top left is the nucleon number or the mass number, which is 64. So this is how we will write it in the internationally accepted notation. So that is your proton number. That is your nucleon or your mass number. Nucleon number or your mass number. So what is the number of electrons in a copper atom? The key thing there is an atom. So the number of proton must equal to the number of electrons, because you want the positive charge of the proton to be balanced out by exactly equal number of electrons, so that an atom is uncharged overall. Okay, as we covered in the previous lecture tutorial. So because you have 29 protons, you must also have 29 electrons in the copper atom. What is the number of neutrons in a copper atom? So the number of neutron is going to be nucleon number minus the number of protons, because this is a relationship. So when you move number of proton to the other side, it becomes nucleon number, this one, minus the number of proton, which is proton number. So it's going to be 64 minus 29. In this particular notation is the mass or nucleon number minus the proton number. That will give you, well, let me put this into my calculator. That gives me 35 neutrons. The next question, again, is this internationally accepted nuclide notation. Top bit is the, not proton. Top bit is the mass number. Again, I have used a different notation, but you should know the mass number is the same as nucleon number. Mass number is the same as nucleon number, and this is clearly stated in the learning objective as stated by the Cambridge syllabus that you need to know both of them. At the bottom is atomic number, and atomic number is the same as proton number, again as stated very clearly in the syllabus as something candidates should be able to appreciate. Mass number is the same as nucleon number, so it's just 2, 3, 5 there. How many protons and electrons? So the key thing there is protons and electrons. So number of protons in an atom, of this, number of protons is 92, and electrons would therefore be 92 electrons, because number of protons equal to number of electrons for the overall atom. Atoms are uncharged, okay? So 92 protons, 92 electrons, all right? So total proton and electron is 92 plus 92 is 184. How many neutrons do uranium have? Number of neutrons is equal to mass number or nuclear number minus the atomic number. So it's going to be 235 minus 92. And there is 143 neutrons, okay? So perhaps I can write that over there. I'll just change it to a different color so that you can easily distinguish that. Alright, so next bit is about completing the following table. Fill in the blank. Each of these is an element. Element, you get it from the periodic table. The proton number, you also get it from the periodic table, because proton number is the same as atomic number as stated in the syllabus. Proton number is the same as atomic number. It tells you the number of protons in the nucleus of an atom. Oxygen has the atomic number 8, so it's element number 8 in the periodic table. The proton number is 8. Argon is 18. Calcium is 19. Calcium is 20 and potassium is 19. So I guess it's there to try and confuse you, okay? To read, think carefully, yeah? This is in group 2. This is in group 1. This is in group 8. This is in group 6. Nucleon number. So again, I like to highlight that the one given in the periodic table is not nucleon number, but it's relative atomic mass. By right, we should have written them as such. Then we can say that it's nucleon number 16, all right? And argon will be, if I take a look at my periodic table, where is my periodic table? So there is 40 and 18, so there is 14. Calcium will be that and that, so there is 40, am I correct? Yep. So they both happen to have the same mass, but different number of protons, all right? Potassium is 39 and 19, so you have 39 nucleon. Nucleon number, what is nucleon number? It tells you the number of nucleons. And what are nucleons? Nucleons refer to protons and neutrons. And where are they located? In the nucleus of an atom. So definition. Until you can get the definition, you will not be able to apply them correctly. So number of protons is equal to the proton number. Very straightforward. Number of electrons in an atom. Okay, for atoms are uncharged. Therefore, the number of proton must be equal to the number of electrons. Relative charge of +1, relative charge of -1. If you have 8 proton, you have 8 times +1. Therefore, you must have 8 times -1 as well. So you have 8, 18, 20, and 19. Your number of neutron is going to be nucleon number minus proton number. All right. So number of neutron is 16 minus 8. 16 nucleon minus 8 proton. All right. So they give you 8. 40 nucleon minus 18 proton, you get 22 neutrons. 40 minus 20, you get 20 neutrons. 39 minus 19, you get 20 neutrons. All right. Next bit, although isotopes are not specifically stated in the new syllabus for atomic structure under the chemistry bit of combined science 5129, I think it's been bundled up with the physics component of the combined science syllabus 5129. I'll cover very quickly because we are dealing with counting the number of protons, electrons and neutrons. Isotopes are defined as actually different atoms. So they are different atoms, but they are of the same element. If they are the same element, that is why same number of proton. There's a key factor there, because they are the same element. If they are the same element, the identity of an element is the number of protons. Same element means same number of proton, but they are different atoms. What are different? Different number of neutrons. They are very, very important. Make sure you know the full definition. Different atoms of the same element with the same number of protons but different number of neutrons. We don't care about the number of electrons because these are atoms, and for atoms, number of protons must be equal to number of electrons. If they are the same element, they must have same number of protons but different number of neutrons for isotopes. For example, chlorine, there are two different isotopes. So this 35 and 37 is what you call mass number or nucleon number. And this is exactly why I said in the periodic table, you are given as 70 and 35.5. This is in the periodic table. And in the periodic table, they specifically even tell you that this is not mass number, this is relative atomic mass, and is given for free in the periodic table as it told you, but that is proton or atomic number. So mass number or nucleon number is not always equal to relative atomic mass. As you could see, here is 35.5, but here is 35 and also 37. Same number of protons because they are the same element, but they are different atoms of the same element with the same number of protons but different number of neutrons. Alright, let's go through a couple of these checkpoint questions. So there are three different isotopes of carbon. This is how you pronounce it is carbon 12, this is carbon 13, this is carbon 14. So all of them are carbon. So I don't care about the proton number because if you know periodic table, you know carbon is unique. It has proton number 6. Alright, so all that has 6 proton. In terms of neutron is going to be the nucleon number, which is the number of protons and neutrons in the nucleus of an atom. Take away the number of protons, then you will get the number of neutrons. Alright, I'm being pedantic here, but there should be plural. So that is 12 minus 6, which is 6 neutron. That is 13 minus 6, which is 7 neutron. That is 14 minus 6, which is 8 neutrons. Next bit on hydrogen. This is hydrogen 1, hydrogen 2, hydrogen 3. They are all hydrogen. They all have the same number of proton. Again, I'm being pedantic. This is singular because there's only 1 protons. And in terms of neutrons, 1 minus 1 is 0. 2 minus 1 equal to 1. 3 minus 1 equal to 2. And there's plural, so I have 2 neutrons there. Same atoms of the same element, which is hydrogen, with the same number of protons, but different number of neutrons. Hydrogen 1, hydrogen 2, hydrogen 3. Carbon 12, carbon 13, carbon 14. Alright. Finally, noble gases electronic structure. So all noble gases have a full outermost shell of electrons, or you will say full valence shell. Full valence shell means the outermost shell is fully filled with electrons. And remember the first shell, you only can accommodate 2 electrons as we saw previously. The first shell, period 1, 2 electrons. Period 2 can accommodate 8 electrons. That's why you have 8 elements across the second period. Period 2. Period 3, 1, 2, 3, 4, 5, 6, 7, 8. Again, it fills up to 8. Then you go to the new period, which is period 4. 1, 2, 3, 4. First shell, second shell, third shell, and fourth shell. So just very quickly, so noble gases are very unreactive. So group 8, Roman numeral, okay, is known as noble gases. Sometimes they call them inert gases, I-N-E-R-T. Inert mean unreactive. Inert mean unreactive. So noble gases are unreactive because of this particular reason. They they have fully filled valence shell, or they have fully filled outermost shell. Helium, be very careful, only 2 valence electrons, but the first electron shell is filled. So the electron configuration of helium is just 2, neon is 2,8, argon is 2,8,8. Alright? So when you have atoms, such as group 1 atoms or group 2 atoms, when they want to form noble gas configuration, they have to gain or lose electrons, and they will form something called ions, which are charged. So again, keep in mind, atoms are uncharged. Ions, IONS, are charged. Ions are charged. Alright, and we'll touch more on ions in the next lecture tutorials, and it'll be more obvious when we cover a little bit more examples. So that's it for this last bit of lecture tutorials on atomic structure, and we'll deal with ions, IONS, in the next topic on chemical structure and bonding. So thank you for watching. Don't forget to subscribe to the channel and follow me at ptet.chemistry. That is ptet.chemistry on Facebook, IG, as well as Twitter if you use these social media. Okay, see you in the next video, and rest out any queries or questions if you see me in school, or just post them on the social media, or even just comment on the YouTube video.